Hey, this is part 2 of the magnet summary. We've already gone over magnets, and now we'll go over electromagnets, which usually students find more confusing. Well, the electro part's electricity, the magnetism part is the magnetism part. Amazing. Electricity and magnetism are closely linked. An electric current can generate a magnetic field, and a moving magnetic field can generate an electric current. We have some characters, and you should know their names. Oersted was the first person to observe electric current produced in a magnetic field. Ampere, and you might recognize that name, developed the right-hand rule. And you have to know the right-hand rule for predicting the magnetic field around a current-carrying wire, whether it's a single strand of wire or if it's a solenoid. So remember that rule. You find the thumb of your right hand. You point your thumb in the direction of the current towards the negative, and your fingers will automatically curl in the direction of the magnetic field. You should know that current always goes from positive to negative in physics. So magnets that produce magnetic fields only when electric current is passed through them are cleverly called electromagnets. You did an electromagnet lab, or we hope you did, and that was studying the effect of voltage, number of turns, and type of core in a controlled experiment. So we changed the voltage, but we kept the other factors constant. Then we changed number of turns, but kept the other factors constant. And finally, we tried different cores while keeping the voltage and number of turns constant. We found more voltage, stronger electromagnet. More turns, stronger electromagnet. And if the core is made of one of those 5 magnetic elements, it's going to be a stronger electromagnet. It's going to work. All kinds of uses for electromagnets: doorbells, telephones, speakers, older TV sets, not the modern ones in the same way, and even valves in your washing machine, your car ignition. One of the advantages of electromagnets is you can turn it on and off. Another is you can make it stronger or weaker. Of course, the disadvantage is if there's a power outage, you don't have an electromagnet. Now, generators, they essentially are the reverse of a motor. So in a motor, you want to get mechanical energy out of your electrical energy. And for a generator, you're using mechanical energy to make electricity. You're also using magnetic energy as well. And so Faraday, you can see almost 200 years ago, made the first generator. We showed you that spinning a magnet near a coil of wire produces alternating current. And it turns out that alternating current travels farther, loses less energy, and so that's why electric companies will ship it as alternating current for great distances. So it talks about how the generator works, and you have a diagram for that, and that was on that page that also had a cross-section of a dam, and you should know why it's alternating current. If we're trying to make more electricity, we can use a stronger magnet, we can move the conductor faster, we can use more coils, those kind of things. A motor converts electric energy into mechanical energy and uses magnetic, and has a reverse function of a generator. So that's it for our summary. Again, make sure you make corrections to electromagnetism questions. Typically, students really struggle with that and find the general magnet questions a lot easier. But do spend some time making corrections and doing that wonderful thing called studying.